Hey guys, I'm here to explain another Infinifactory solution. This time I'm doing Control Console. Let's check it out. Okay, so as always, let's start with our output. You can see it's this bank of computers, and it has this right angle, and so it alternates computer, lever, computer, lever, computer, and then there's computer, computer, and then there's this corner 45-degree piece that joins them together. Now let's look at our inputs. Over here we have the bank of 3 computers, but remember it alternates computer, lever. So we have to use this, and we have to basically get rid of some of the computers and insert levers. And then over here we have the levers. Yeah, right. Those are the levers. Levers right there, and this is the little 45-degree piece that will join the various computer banks. So we have 3 computers, so just looking at it, we know we're going to need a minimum of 3 of those inputs to make this, because we're going to need 1 to make these 2 computers on the side, and then these remaining 5 elements, well, each input is 3 long, and we need 5 here, so that's going to be another 2 inputs. So it's going to take 3 rounds of inputs here, and then 2 rounds of lever inputs, and 1 45-degree angle input. So I decided to, first off, just get 3 inputs, and then split them up. So 1 goes here, and then this sensor triggers the pushers, which make each input do its own thing. And so I decided I was going to have 1 input become this. So I was going to shave off just this top left part of the input, or so I could put the 45-degree piece there. Another one was going to be these 3, these left 3. And so I was going to shave off just this middle lever. And then this one was the tricky one. I had to shave off the lever. I also had to shave off this front right, the entire column, because the lower piece down here, it's not visible, but imagine the piece directly below this 45-degree angle. That's actually coming from this set of 3, since I just shaved off this top one, so that one already has a bottom, so this one can't have a bottom as well. And I'll show you. So first, we'll just see the one that gets this middle shaved off, and that is this second one. You can see it just runs right into one of these things called eviscerators. Eviscerator, yeah. Runs right into an eviscerator and then falls down. Now, this rightmost piece that gets just the top left shaved off is pretty much the same. That's just an eviscerator right there, and it falls down. And so now the tricky one was getting this the left top piece and then both right front pieces. So that is this one right here. And so I had a nice little system I did for this. So I have it sit right here and basically await. You can see these eviscerators. This is kind of a moving, freestanding fixture that's going to get pushed forward, and they're just in the right spot. There's these front 2 on the right hand side, and then the top left front one right here. And so first off, this platform comes, and we'll just sit here and wait for it. This will trigger this sensor, which will release the blocker, which was preventing these from going forward. And so this drills in, eliminates what we want, this and these 2. And then we have another conveyor belt that's going to push it back out. And you'll notice here I have the counter sensor, which is triggered to only activate every other time. So when it's moving forward, it doesn't activate. And then once it gets pushed back out, it will activate. And that'll trigger this pusher, which will push it here. And this has conveyor belts both from the top and bottom. So that's going to overpower the single conveyor belt going this direction. And this will slide it back. Sensor pushes it back on, and it's right back where it started. So you can see a couple cycles of what this looks like. And so I got that, and then now my question was, now that this is drilled out, how do I send it along its way? I could have a pusher here, but then I would need to have this approach from a different way, because if I had a pusher, it would block its approach into this little station. So I thought about that, and then I just realized, you know what, I'll just wait for the next one to come along and push it out of the station. So since this panel is waiting for the second one to push it along, I had to do that same thing on the other two. And so you'll see right here, this one is sitting, waiting for the second to push it along, and this one is sitting, waiting, well, it's about to start sitting, waiting for the second to push it along. And that helps the timing work out, so that they're all delayed about the same amount of time. And so yeah, it just becomes a matter of these ones that fall, they rotate, wait, and then everything kind of slides into place right here where I'm going to assemble everything. Sorry. So you can see the far left piece wasn't hard, just gets pushed in from the left. This one gets pushed in from this direction after it's rotated. And then this one will slide in from the back. And now you're also seeing other pieces falling into place. Those are these inputs up here. So I also had these, had to sit and wait to get pushed. We'll start with just with the corner piece. It had to be rotated. And so this actually has to wait for the third one to come along. And that's just the way the timing worked out. And that's just, really you have to get the very first assembly to work out. And then since the everything's coming at fixed intervals, these should all be coming at fixed intervals. As long as the first one works out, in theory, the rest of them should work out. So even though this one takes 3 inputs and this one takes 2, these all take 2 inputs, it's because this is just taking a more direct route, and these are kind of going around all over the place. So that one falls in and lands there. You'll notice it doesn't get fused. I'll talk about that in a little bit. And then these do about the same thing. I have a sensor, every other one gets pushed onto the second track, and kind of just some delays here to make sure everything times out right. You'll see this one also has to wait for the third one. This one only has to wait for the second one, because once it's on the rotating platform, and then it gets pushed along. And that's just the way the timing worked out. I had to play around with it. Yeah, so you can see how the timing is. Everything kind of falls into place. This is quite close with this one. Well, it's actually quite close with this as well. This falls into place right as it slides in. This has plenty of time sitting there. And then this one's about to fall, and its slot is right here, so you can see just how tight this timing is. And it just gets it. And so now another important thing is, now that this is all assembled, it needs to be pushed along. And notice it's actually still 3 pieces. It's this very small piece right here. It's this bigger piece. And that does not include the bottom one under the small piece. And then there's this part, but that does not include the small piece. And so, if I guess I could have pushed it, had this one come in and push it, but I would push it over here, and I guess that could have worked. I could have had some conveyor belts here, but I thought it would be much easier if I had this one come along and push it, since that pushes it directly to the goal, and it's lined up with the goal anyways. So I had to add some roundabout pathing for this one, otherwise this one would have pushed it first. But the way it is, it just times out that this path is actually the fastest, so the push it gets off the platform will be from this direction, which pushes it right along here. And then I have the conveyor belts right here, and so once again, these 2 are not attached to this, only this was pushed, but just due to the positioning of this and this, they're directly in the way of this, and so the whole unit gets pushed even though it's not fused together. And same with the conveyor belt, it pushes this, which pushes everything else. And then the 2 fuses, essentially I need to fuse this. I fused this to the small one first, and then this plus the small one to the rest of the fixture, which is right here. So very last thing that happens before it goes in and it gets counted. So this one was one of the more challenging puzzles I've done so far. And it's not a particularly clever solution, but this was actually my second attempt at it. I tried this puzzle yesterday and just wasn't able to get things to time out, and so I kind of started over from scratch today. I did pretty much the same approach, but you know, sometimes it's best to just start from scratch, and I got it all to work this time. Oh, and I never really mentioned how the fusing works here, but due to the way everything slides in from the back and from the sides, there was nothing to stop me from just putting the fuses right here for the falling pieces, and then just two on the top for you know, the two panels. So this panel plus this panel. You can see this one fell in, got fused. This one's gonna slide in. And then this one from the top will fuse them together, and then this one on the side will fuse the falling lever. I really like the little drill situation I had here. I thought that was pretty interesting. Now that I think about it, this is really inefficient. I don't see why I couldn't have just done this. Well, let me try something. I'm about to blow my own mind. I'm pretty sure this is just going to accomplish the exact same thing, which means the timing... Yeah. I could have just done that. I don't know what I was thinking with this whole system. Way over-engineered it. And that's the thing that caused this stopping on the platform and having to wait for the second round of everything and all the timing problems I had. So, hindsight, I could probably make this a lot faster and less over-engineered, but it looks cool, you know. That's something. And it doesn't perform too bad. It could be faster, because really, there's only that, you only have to pay the penalty for that delay on the very first iteration, and then the throughput is the exact same as if you didn't have it, so. But pretty decent. Hope you enjoyed. Thanks for watching.